but use the Q&A section as questions come up. I want to thank everybody who made it for making it and investing your morning, afternoon, evening, depending on what corner of the world you are with me today. And today we're going to be talking about algorithmic bias, AI bias as it's called in the field. And quick context with the proliferation of large language models, generative AI, I don't want to mislead. This has nothing to do with, well, this has little to do with generative AI and large language models. If you want to learn more about that, I gave a previous talk an hour ago. At 4:30 Eastern Standard US. Talking about where I did a demo fine-tuning a language model. Today, though, is more traditional machine learning focused or what they call now narrow AI. And so I'm in the thick of research for an upcoming book, and this is one of the key chapters. I've given this talk a few times, and so again, thank you for joining. All right, so I want to launch right in with this point, how we propagate our bias. Humans are not perfect. It's not a controversial statement. And we encode our biases into the data that we use to train artificial intelligence. That's not new. Everyone who's ever tried a ChatGPT or even heard about artificial intelligence, we know that these probabilistic systems are trained on data that is generated by humans, that it may be inherently biased because, I, for example, I'm biased in ways that I may or may not realize. And so I will give a quick example later, but today police departments around the United States and perhaps even outside where you are in the world use algorithms to help them figure out where to send resources. However, machine learning algorithms today are not causal. Like they're correlative. They are, their prediction. For the most part, they're predicting based on correlations and not causality. And we all know that correlation does not equal causality. All right. Back to the police thing, an algorithm can't understand if an arrest was unfair or unjust as a result. It just sees an arrest. And the algorithm is going to send police where it thinks a crime might be based on, the data that it has that was fed into it. But on its own, it doesn't understand that traditionally, this is where police have always sent resources. For example, in neighborhoods where a lot of people may look like me. Therefore, that's where these algorithms see most of the crime. This lovely photo is of Richmond, Virginia. I do not know who to attribute this photo to, but it's Virginia in the United States. I'm crossing the road one day 16 years ago, 18 years at this point, sorry, and I get stopped by police. I got pinned to the ground. We know how that story goes. I joke today because that's in my line of work, I call that a flesh-based API or a flesh-based machine learning algorithm because they misclassified me as a criminal where I was just going to the gym after leaving work one day. And so therefore, a lot of law enforcement in that area might have seen someone like me, maybe in the past commit a crime. Sometimes flesh-based APIs might egregiously and unfairly misclassify people, like these gentlemen who are just sitting at a Starbucks a few years ago, waiting for a friend or drinking a coffee, whatever they were doing, and having someone just call the cops on them and them getting arrested, leading to Starbucks apologizing for that, what they call a mistake. Therefore, that's where law enforcement makes arrests in these same communities. Therefore, more resources are sent there. Therefore, the data that we have access to train these models are traumatized, and the output of the machine learning algorithm leads to more prejudice and assumptions, leading to, again, new harms amongst often traumatized individuals. And it's like the worst flywheel, right? Worst cycle that one can imagine. And if you're affected by this in your community, know that, some people like me and many other brilliant minds, more brilliant than I, are working on ways to make some of these systems fair, and by fair, a little bit less bias. And for those who are probably rolling their eyes in the audience, I always get those thinking, oh, well, what's that got to do with me? It's like, well, for some communities, maybe your neighbor, if you're not affected, there are some startups thinking they have cracked precognition from Minority Report. And it's pretty scary when you realize that even the Justice Department in the United States has no idea how many of these predictive policing algorithms are already in place based on a report. And so, again, very concerning, but these are the realities that we live in. And I, for example, going through the trauma that I've been through, and one Thursday morning, perhaps 18 years ago, want to be able to be available and to raise these two lovely girls who I call my daughters. And I also want to be a good ancestor for some of these intelligent systems that we're building. And that's why I'm in the field that I am. In case you're wondering, I'm Noble Ackerson. I work for a technology consulting firm outside of the nation's capital in the United States, a company called Ventera Corporation. And in my day-to-day, I care about responsible use and delivery of artificial intelligence systems for some federal, United States federal customers and some commercial customers as well when I'm given the opportunity. That means on any given day, I'm advocating for teams to leverage human-centered design, human-centered machine learning best practices, from things like, explicit or implicit ways to track human feedback, or even for the development process where, users are, my developers are developing model cards in order to track the lineage and the provenance of the data that they're using to train through, let's say, a machine learning operations pipeline. I'm also helping, today I'm going to be talking about fairness and bias a lot. So helping teams and evangelizing for our data scientists to use these algorithms that I'm going to be sharing here shortly. I'm also, implementing human interpretable models, either baked into the system that we're using, like SageMaker, or going off the shelf to using libraries like IBM's, explainability libraries, or even SHAP or Lime or integrated gradients, depending on the use case. That means I'm designing and implementing privacy-preserving capabilities, implementing data into AI for better governance of the AI, or even just developing synthetic data so that I can rapidly prototype, like I did about an hour ago, rapidly prototype something without using sensitive information or protected health information, or even worse, personally identifiable information. Using synthetic data and other privacy preserving technologies enable this to happen. So designing and delivering more robust and secure learned models. Nothing worse than getting, framing your problem, collecting the data set, making sure it's perfect, handing it off to a data scientist or an ML developer to build, only to serve this model, integrate it into software, and find out that someone, reverse hacked a prompt or something like that, and owned your system, right? And so I'm not directly working in security for AI, but I hope and will continue to be an influence as far as my day-to-day is concerned. And it's impossible at the moment to continuously integrate all of these components. Fairness and bias, in my view, only applies in a few narrow cases. But when you have the opportunity, having the right tools that I'll go over today, And today we're going to go over twofer, because I'm going to talk about explainable and interpretable models as well. Just lightly touch on that because, again, the old adage, you can improve what you don't measure. So let's get started. When I'm giving this talk, I was just in Atlanta for a conference called Black in Tech, and I asked the audience, what's your time to AI this morning? And I met with a deer in the headlights, blink, blink, and no one knows how to answer that. And so then I go, how long did it take you from being dead asleep to interacting with an AI? And so far, I've asked that question every single time I give this talk, and I get an average of 3 minutes. Sometimes some people say 5, some people say 0, some people say 1, some people last Thursday I got 20 minutes. Okay. If your battery and if you use your phone for a modern phone for an alarm, for example, like I do, and your phone is optimizes the battery life, you're probably waking up net zero with AI. You're influenced by your AI is so ambient and it's working for you that in my opinion, if it's going to be so ambient and ubiquitous in our lives, it needs to be fair. Okay. If it takes a few seconds to figure out what features of your phone are, for example, powered by AI, or walking through an airport and trying to figure out why you were pulled aside for a random check, that kind of stuff. These systems better be fair. If you stepped outside your hotel and you ordered an Uber in a financial district, maybe, and you got one fare, but then did the same thing in another part of town and got in the same distance, got an egregious number, there's price discrimination happening, which is an actual term that is driven by machine learning or artificial intelligence, right? And so this is all, things that we have to think about. And a quick beat about, I want us to take a second about the United States. There is no legal doctrine. In the United States, there are two legal doctrines when it comes to fairness, right? There's disparate treatment of individuals, and then there's disparate impact. Treatment is the goal of which is just procedural fairness. You're not going out and intentionally harming people. Disparate impact is distributive justice and minimizing the difference in outcomes for groups of people. Group fairness, in the broadest sense, I guess, segments people or populations into groups defined by protected classes or protected attributes, like, your race, your gender, that kind of stuff. And so as you're building these systems, look into whether you're collecting this data for a justifiable reason and act accordingly. Use my 3 C's if you want. Provide the context, understand your data, provide the context to the users. So that's 1 C. Go give them the choice to opt in or opt out, and then the controls to then act on exporting their data out, for example. Fairness is really, really hard. I remember the story that the news article that really got me to actually create these slides 2 years ago was when a gentleman using Google Photos, when Google Photos first launched, realized that he was classified as a gorilla. And believe it or not, even today, Google Photos and Google Images have some issues with it that they're still working on as well. And it's not because someone at Google is racist. It's just because fairness is a really hard thing. How do you mathematically quantify fairness, right? It's really tough because there's no single definition of the thing. There's no single definition of fairness. And we have to talk about fairness, by the way, before we talk about bias. And that's why I'm anchoring on this for a second. You also can't guarantee fairness in an AI for an intelligent system or an AI application, right? What's fair in Ohio may not be fair in Baghdad, right? Or Lebanon, or, Beijing. Like and then what's fair today in California may not be fair tomorrow. So fairness is really hard. I'll cover some metrics, and there are a few of those. These are some from IBM's one of IBM's projects called 360 Fairness, I think it's called. I don't seem to be able to get to their page anymore. They might be transitioning sites. It sounds like Microsoft has open source something similar called Fair Learn, or they have just baseline metrics. You don't really need to solve every single case of fairness, but you can actually sort of generalize and find sort of baseline things that we know may be useful. The hardest part about using one of these metrics in your mitigation strategy is picking the right one. And I'm going to intentionally pick one that brings a lot of agita to some people when I give this talk. I get a lot of people who object to one way or one of these metrics, and I just want to use that to make a point of how hard this thing is here in a second. I think we should move on. I want to sort of define what we mean by bias in the machine learning, artificial intelligence context. So pay attention to this slide. If this is one slide, if there's one slide in this talk that you have to anchor in on, take a screenshot of this it's attributed to, it's adapted a bit, but it's attributed to Cornell University authors, and it can be found on Archive. And that's in the bottom right-hand corner. That's the resource there. It's just search for catalog of biases. So from a statistical bias standpoint, bias starts with the data up here. We'll say number one starts with the data, and then algorithms transmit it, and of course, then our users are the receivers of interact with this data and are able to either suffer or see some harm or some opportunity denial based on that. If I were to, it may be improved now with Google, not picking on Google for any reason, but just the most used search engine out there. So I'll say if I were to sort of search for, from a historical bias standpoint, list a bunch of physicists in history, I'm pretty sure I get a predominant white male listing, a listing of people. And like I said, it all starts with the data. That data is trained, fed into some LLM, and voila, you have ChatGPT telling you that there are more male physicists. Maybe that may be true, but what's fair to you? If I'm trying to teach my daughters that you saw that they can be physicists too, they may want to see representation. And I'm sure there are female physicists out there. And so just to wrap this section up, the definition section up, bias is a human way to shortcut decision-making at a subconscious level. And we care about debiasing our data and making sure we unit test our machine learning process for any bias-related issues, because it affects our consumers. You don't want your customers to undertrust your system because they won't use it. You will lose customers. You don't want them to feel othered or insulted after using your tool. You ultimately want to increase adoption. For your engineers, you want them to create better algorithms. You want them to understand what's happening behind what's often called a black box model. And so being able to sort of run some of these tests help you better understand what you're dealing with. Of course, if you have been following, the rise of data, the rise in breaches and rise in regulation, regulators around the world are paying close attention to artificial intelligence, as they have done for years with data privacy, and even with more urgency. And so if you don't want, the feds to come knock on your door, you may want to, we're all impacted by fairness. And in one such point, one of the strongest language that I've ever seen from the US government is this one where, you may be facing a complaint alleging violations if your algorithm results in, credit discrimination against a protected class. I'm going to speed through this. AI bias affects hiring at work. If you're employed, whether you get a promotion, whether you get recruited, it's all algorithmic now, and more, even for, XR use cases. This is an example of how bias, they use tools to understand personality and cultural fit with these automated interviews, where, with this test, from this paper, just adding a photo behind this person made this person less neurotic, which I find hilarious. I talked about protected classes. These are the classes to the right. And so practically for you, when you go to work on Monday, and you're working in this field, you want to ask yourself, whether, you're using data sets that specifically fall into one of these protected classes, especially if you're in the United States. And if not, even if you don't, and maybe you have a justifiable reason, do you have data that just directly correlated to these protected classes? Affluence, for example, you may not collect race or income, for example, but location data might infer that as well, right? So you want to ask yourself, am I basically keeping someone from an economic opportunity? And if so, pay attention to it, because if you're in the U.S. anyway, the FTC, Federal Trade Commission, is coming after you if you get on their radar. For the developers in the room, I want to make this very, very practical. And so we talk about bias. Everyone talks about bias. I'm actually on the technical side. So, how do we translate these fairness principles into a JIRA story so that you can actually sort of deliver something that's fair and ultimately harmless to your audience? There's a lot that goes into defining the problem and collecting your data. You want to make sure that even before we start, what I'm going to call pre-process, oversimplifying here. You want to make sure that, where it matters, you are getting informed consent of the people's data that you're collecting. There's no collection bias. There's no, you want to limit PII exposure, either direct protected classes or not. And then even downstream, that you have some mitigating tactics for that. But as you're actually going through the machine learning workflow, again, we're focused on narrow AI here. TensorFlow, for example, has a what-if analysis tool. It's fantastic for you to sort of give it scenarios like, what happens if I remove this protected class out of my data set and replace it with whatever? What does that look like? I gave... FairLearn has a bunch of pre-processing, in-processing, and post-processing algorithms that you can use. And then, of course, there's libraries that you can pull in to explain or interpret the feature importances of your models. And those are either, if you're using an ecosystem like Google Cloud or SageMaker on AWS, they come bundled with some of this stuff, but sometimes they don't, right? And so you can augment some of these libraries with an open source solution. And again, I always say, for developers, you want to sort of limit the amount of noise. Data skew is a form of noise, or bias is a form of data skew. And so you want to be able to debug. And to do this, you want some sort of pipeline. You want a data pipeline that is, that sort of helps you, either real time or batch your data in. You want a feature pipeline, with a feature store. You want a training pipeline with experiment tracking, model store as well. And you want an inference pipeline as well. Again, if you're fortunate to be using like a platform tool, you might have all of this out of the bat. I was going to show, and maybe I should show some code for my developers in the room. I'm going to stop sharing for a hot second and reshare, but this time I'm going to share the window. All right. How do I do this in 4 minutes? All right, let's do this. All right, so here I'm using, if you've ever done a Kaggle competition or try to find a data set on US adults, there are many variations of the adult data set you find on Kaggle. So I'm using that. And here, I'm going to show only two parts of this. Here, I pull in my data. I'm using a decision tree classifier to try to understand the distribution of my data as far as income is concerned, specifically like $50,000 or $50,000 a year or more. And when I slice and dice this data, I learn that it's about females are before I use a bias mitigating tactic or an algorithm to sort of debias, right? And basically using a fairness metric or of sorts to debias this. So 6% of the females make over 50K in this data set. Again, this is just a demo. It's from 2014, so it might not be the case today. And males are whopping 21%. And so in some cases, you might say, oh, well, for my use case, hopefully narrow use case, we might want every, male and female to be at 60%, right? Or what have you. We want to treat both genders equally when predicting who makes more than 50K. And so we're going to use the same decision tree classifier here, but we're going to use one of our algorithms to debias it. And here we see that we've improved this where we're bringing them to parity. Females are 15% and males are now 17%. And now you might ask, is this the best way to ensure fairness in applications that are coming through with my little fancy machine learning application app or my AI application recruiting app? Well, many might say no, because demographic parity ensures that the selection rate is literally equal. Literally, that's what it means. Like demographic, like male or female, parity, like equal across both all groups, right? I'm just using two classifications of gender here. In real life, there'll be a whole lot more. But it doesn't take into account the underlying qualifications or the suitability of the candidate, right? So, use with caution, right? So here, I'm saying, basically this is the same thing. This is the same data. This is before in blue here. This was before male versus female. This is after, where we've mitigated it and we bumped up females yet. But again, just to end this, in practice, achieving strict demographic parity might require some careful consideration, right? Like I said, there's a lot of factors that go into this. So don't just use this and say, yay, we've solved equality in our system. It's a widely used concept, demographic parity, but it should be applied very thoughtfully or selectively based on what you're trying to do. All right, really speeding through this thing because I only have a minute left. You can't improve what you don't measure. Traditionally, some of these systems, especially very complex systems without any explainability testing or libraries in your system, you give it an input feature, go through a data transformation process called machine learning or machine training the machine learning or teaching the machine, and you get spat out a classification, prediction, or recommendation. But you might be wondering, like, why did my features, which features were more dominant? How do they relate? Why did the model predict this? This is where, Shap, Scott Lumberg et al. and from Microsoft, I believe, Microsoft Research, and others came up with something called Shapley additive explanations, I believe, in order to, give you better understanding of the features. Really, really quick. I've got about a couple seconds left. This is a Boston data set, another one I pulled from Kaggle. And you'll notice the big old red, this part here is basically saying that of all the features, every single one of these are features. So you've got age, crime, tax, that kind of stuff. The LSTAT is lower status of population, basically saying, the portion of the population that is lower status by, I guess, statisticians have defined it to be. And so this has a lot of influence on the model's prediction, right? So how you interpret that matters. If you remember, Amazon rolled out same-day delivery years ago to the US. The blue here are when they were rolling out same-day delivery. Blue coverage is people that they were places that they were going to cover, and gray was places like Roxbury, Boston. They chose not to cover. And this was all algorithmic, right? It was not one person deciding to reinvent redlining from Boston, but that's literally, if you overlay the redlining map from the 70s over with what Amazon did, it was almost a one-to-one, right? It's not because Amazon is racist, again, just bringing that full circle. It's because Amazon was predicting the number of purchases, which correlates to affluence, which correlates to race in the United States. And Amazon, again, did not look at their customers' races at all, probably. I'm not in the room when they made that decision. Not going to go over this. It sort of talks about the different parts where you can actually put in your algorithms. Tests, I've already talked about that. There's a lot of tension between between accuracy and fairness when you try to implement this in the real world. There's also bias and privacy. You can deploy a fleet of self-driving cars, but to sort of learn how to drive, but then they have to sweep up a lot of individuals and pedestrians and all that stuff, and you can't go in for every single one and ask consent for them. So there's a lot of tension there. I certainly don't have the answers to that. And so what is fighting bias with bias? Just to close this out, what is basically an acknowledgement of that humans aren't perfect and we propagate our biases in what we do. It means what is, recognition that we already introduced bias into the process to improve the performance, accuracy, and optimizing for errors, and maybe we need to constrain those optimizations. And then what should be putting these tools into practice? We just want to ask ourselves one last question, which is what I'm building going to harm people, or at least deny someone an opportunity or a group of people of an opportunity? And I hope this talk has been insightful to you, and that it can help you eliminate your own traumatized data. And so with that, I'm at Noble Ackerson on YouTube. I have a lot of these talks on there and on Medium, of course. And thank you again for joining.